What is up, amigos? Today we're going through isolated wheel aerodynamics. We're going through stationary wheels and rotating wheels. So an isolated wheel is where we don't have a wheelhouse around it, we just have it out in the open. So for example, in F1. And the biggest problem with this is that this particular situation is actually the most draggy situation for wheels in general, which is why if you look at F1, for example, where the wheels are completely exposed to the outside, they go to so much effort to redirect the flow in certain ways to reduce the drag of these wheels. So this is really the worst case scenario. On the left here, we have the stationary wheel. On the right, we have the rotating wheels. And we have the flow coming in for both of these. And often they hit the front and we get stagnation pressures, and at the back we get a wake. Over the top it might separate. And this results in a lot of complex flows, which we'll go through in a second. So we have the side view of each wheel, and back here we have looking at the back of the wheel. So for the stationary wheel to begin with, we have quite a few vortex structures. Looking at the back here, we have a couple horseshoe vortices coming from this like contact patch area and the front shoulder, and they rotate inwards. Then at the back of the wheel, we have this horseshoe vortex which forms just around here. And then over the back part, we have two vortices coming off the back, which then rotate in opposite signs as well. If we rotate the wheel, there are a lot of similarities between this one and the stationary wheel, but there are some differences as well. And in general, this is a little bit easier to understand because we have fewer vortices and some of the vortex systems are more connected. For example, behind the wheel, if you look at the rotating wheel, we have a vortex ring happening now as opposed to just two vortices coming down from the back of the wheel. If we look at the contact patch area, yes, we do get the horseshoe vortex again, and interestingly, it gets squished a little bit behind the wheel as opposed to this is a little bit fatter. And at the front of the wheel, the contact patch and the shoulders, we actually lose one of these horseshoe vortices, and we have one here. As we go downstream, it's very common for these vortices to merge with the vortex line of the same sign, and then it's become one mega vortex. So that is the aerodynamics of an isolated wheel. When we put a wheelhouse around it, then it changes slightly, which we'll go through in the next video. So if you like this video, make sure to like it, and if you want to see more like this, click the subscribe button. And if you want to learn more about aerodynamics of wheels and cars in general and race cars, check out a course by JKF that they put on to teach you about automotive aerodynamics. And it's really nice because if you like stuff like this, they go through the fundamentals, so the basics and the theory, as well as the applied section of it. You can find that in the link in the description. And see you. Peace out, amigos.